I drink some tea, but I don't know if that counts as breakfast.
Good. Shahina, now for maybe 1 or 2 weeks, maybe 1 week, we will see. One session, we will do some revision, okay? We'll talk about factors and multiples and rational numbers, integers, how to add them. And one session, we will continue our class, okay? As you know, the last time we were learning about perimeter, right? And area, okay? We will do like this. And so that also you will actually, how to say, learn about the chapters, because at the beginning I thought you were good in like integers and rational numbers, but now I noticed that still you need to practice some questions, okay? Now, if you remember last time, I gave you some questions for revision, so maybe you did some of them, but I think you may not finish all the questions. So we will see those questions together now, one session. Today, we will talk about, again, the factors and multiples. And one session, we will solve problems about perimeter and area. Okay? So just relax. You don't have to actually, how to say, stress about this, okay? Relax and try to understand what's going on here. And after all, practice makes you perfect, okay? Maybe one time you do this, you don't understand. Second time you do this, now you have some idea. Third time you do this, now you can do with more self-confidence. Now maybe next one more time you do this, okay, now you have no doubt, you know what to do, right? So after all, it's a, you are now in a kind of transitional periods, because you are, how to say, just changing your life from primary school to secondary school, because math in primary school, math in secondary school, it is different. In primary school, we just call this math, but usually in secondary school means grade 7, 8, 9, 10. We call this algebra and geometry. And later, we will add trigonometry. Later, we will add statistics and probability. Later, we will add the calculus and blah, blah. Okay, so if you are having some difficulty, it is no problem, okay? Just do not give up. Relax. The idea doesn't come. And just you need to have some rest, okay? After the try again, all right? So I hope you will actually be really good in math maybe in 3-4 months. We don't have to rush, okay? All right. So, Shahina, revision chapters. No, I need to open with. Okay. You can see, right, Shahina?
Yes.
Good. All right. Okay, Shahina, how we solve these questions? Okay, so you will read the question, and if you don't understand, you read one more time, okay, and tell me your idea and method how you will solve this, okay, and after that, I'll just write it down, your idea here. Let's start with the first question. Read it.
John has 48 orange flavored sweets, and Susan has 45 lime flavored sweets. John wishes to divide his sweets equally into bags. List all the possible ways he can do this. For example, he can have 6 bags of 8 sweets. Oh, that makes sense.
Okay, so John has 48 orange flavored sweets, and Susan has 45 lime flavored sweets. Okay. A. John wishes to divide his sweets equally into bags. List all the possible ways he can do this. For example, he can have 6 bags of 8 sweets, right? So we can just do this. Now 6 bags, maybe we can add this. How can we do that? Now, if I just write here, number of bags, right? And here, sweets inside that bags, right? For example, if you just have 1 bag, actually here we are talking about all the factors, right? 1 bag, and each bag has how many sweets? 48, right? So we can have 2 bags. Each bag contains how many? 24. And 3 bags. Each contains 16.
16.
How about 4? It is 12. What is the next number? That's a possible number.
No, 6. 6.
Not 5, then 6. 6. If it were 48, it is 8, right? How about if it is 8 bags? Each bag contains 6 sweets. And next number is
12.
12, right? Each bag contains 4. Next number?
16.
16. Each bag contains 3. And
That's a lot.
24, right?
Yeah.
Okay, let me just write here 24. Then each bag contains 2. Then one more. 48. So each bag contains only 1 sweet. Actually here, that means it's all about factors, right? These numbers, this 1, 2, 3, 4, 6, 8, 12, 16, 24, 48. Yeah. We call these numbers the factors of 48, right? Okay, that means that it's the same question. Just list all the factors of 48. Okay, so John wishes. We already answered this question. And question B, what is question B?
Susan also wishes to divide her sweets equally into bags. List all the possible ways she can do this.
Okay, Susan has how many? 45. So Susan has 45 sweets. So if I just write again, make a list. Okay, the first one, it actually gives the number of bags. The second one is number of sweets in each bag, right? So if you just have 1 bag, that bag contains 45. What is the next number?
5.
3? 3, right? 15.
Oh, we can, yeah.
Yeah, next number is 5. If it is 5, this one is?
9.
5 bags. Each bag contains 9 sweets, right? Next one is 9 bags. Each bag contains 5 sweets. Next number?
15.
15. So each bag contains 3. As you see here, we are just repeating, right? 1, 45. Now it's 15, right? 15 is 3. So next number is before 15, what number? It is 45. So when it's 45, it is 1. So these are all the possible numbers, right? The possible bags. So that each bag contains some sweets. Okay. Let's read question C.
Peter, their good friend, suggests that they combine the sweets and divide them equally into bags. Has equal number of orange-flavored and lime-flavored sweets. Explain how this can be done.
Okay, what do you think? Now, actually, these guys, they are going to prepare, maybe they want to prepare some kind of gift, right? So they want to put some, we have 2 different sweets. The first one is they want to put some orange flavored sweets and some lime flavored sweets. So that means that how many bags of gifts we can prepare, right? Using this 48 orange flavored and 55 and 45 lemon flavored sweets, provided that every bag contains the same number of sweets. So that is 48, 45. How can we answer the question?
So on the table that we made of bags and sweets for each number, maybe we could find like the numbers that are similar. Like,
okay.
I don't know if you like understand that, but.
All right, combine the sweets and divide them equally into bags, right? Divide them equally means, if you just write this, we can divide this by equally. For example, can we just make 3? Let's first divide them, right? Divide by 2, only this number, 45, 24. Divide by 2, 45, 12. Divide by 2, 45. What is it? 6. Divide by 2, 45, 3. Now divide by 3. Okay, we'll start. It is 1, 15, right? And divide by 3, here 5. Divide by 5, it is 1, right? So now the question is, Peter, that your good friend, suggests that they could combine the sweets and divide them equally into bags. Has equal number of orange flavored and lime flavored sweets. Explain how can this be done, right? The only way is actually we can put only into 3 bags, right? Either actually 1 bag, because 1 is always a common factor. If I just put 1 bag, for example, in this bag, how many orange flavored sweets? 45. And the second type, 48. How about if we put them into 3 bags, because both numbers are divisible by 3, right? So 3 bags, then each bag, right? Each bag contains how many? The first type, it is 15, right? The second one, it is 16. So maybe if I just put number here, our first bag, this is our second bag, this is our third bag. In the first bag, 15. Second bag, we put again 15, orange flavored. Third bag, 15. The second flavor, sweet, we put 16, 16, right? So each bag contains 15 of the first kind, 16 of the second kind, right? As you see here, each bag contains the same number of each flavored sweets. So that means that to answer this question, we need to find such a number that divides both numbers. That means that that is the common factor of these numbers. Okay?
Yeah. Okay.
Good. All right. Question 2. Read the question.
James wants to cover a floor measuring 90 centimeters by 120 centimeters with square tiles of the same size. Given that he uses only whole tiles, find the largest possible length for the side of each tile.
Okay. Did you understand the question? James wants to cover a floor measuring 90 centimeters by 120 centimeters. Okay, actually here we have a kind of floor, right? Rectangular. So the length is 120 centimeters with 90 centimeters. Okay, that's the first part of the question. With square tiles of the same size. So we have square tile. Do we know it is size? We don't know. Let's say this side is n, also this side is n, because it says square, right? Square means all sides are equal. Okay, the same size. So given that he uses only whole tiles, all right, we are not allowed actually to use like half or broken piece of tile. Okay, you need to use only whole tile here. Then the question is, find the largest possible length of the side of each tile. So it means that if you are going to cover this floor with tiles, what can be actually the largest possible side of this tile? How big can it be? To answer this question, here I will put some tiles right in this way, in this direction. Again, those tiles here, then I can cover, right? And also here we have tiles here, and tiles here, right? That means that this n, it should be divisible by 9. No, actually, it should divide 90, and also it should divide 120. That means that this n must be, it says largest possible, right? So this n must be highest common factor of 90 and 120, right? After that, because we are looking for the largest possible number. Now, if you find this 90, 120, Sabta Shahina, okay, you can divide by 2. But if you can see any common factor, you can divide by the common factor. If you look at these numbers, what is their common factor? Can you tell me?
10.
10, very good. Now 10 divides both numbers, right? Let's put start here. If you divide by 10, it is 9 and 12. Still they have common factor, right? What is another common factor? 3. If it's divided 3, here we have 3, here we have 4. They don't have any common factor, so we can stop, because since we are looking for only ACF. If you're looking for LCM, least common multiple, at that time we can continue this division, but we are now looking for that. So what is the highest common factor of this number? That is 10 times 3, which is equal to 30, right? So actually our tile can be 30 centimeters. Now if you put this here, 30, how many I can put here? 1, 2, 3, 4, right? So that is 30, 30, 30, 30. So there's 120. How about for width? It is 30, 30, 30, 3. Right. So how many tiles? Just 12 tiles will be enough. Okay. So the largest possible tile must be, what is it? 30 by 30. It cannot be greater than this. Okay, because the highest common factor of this 90 is this thing. And how about question B?
Find the number of tiles that are needed to cover the floor.
Find the number of tiles that are needed to cover the floor.
Okay.
Right? Okay, we don't have C. So how many tiles we need? 12, right? Because here we have 3. How can I find this? 120 is divided by 30. That is 4. That is for the length, to cover the length. How about the width? 90 is divided by 30. That's equal to 3. Here we need 3. So all together we need 3 times 4, 12 tiles.
Oh, that makes sense.
Okay.
Okay.
Good. Next question.
Paul has 3 pieces of rope with lengths of 140 centimeters, of 168 centimeters and 210 centimeters. He wishes to cut 3 pieces of the rope into smaller pieces of equal length with no remainders. A. What is the greatest possible length for each of the smaller pieces of rope?
Okay, what is the greatest possible length? It says greatest, that's a keyword, right? That's the greatest possible length of each of the smaller pieces of rope. So what is the greatest possible length? That is, what is it? The highest common factor of these numbers, right? Because that pieces, I can just divide them into smaller pieces whose length is, like, for example, 1, right? Yeah. So this will be 140 pieces, this will be 168 pieces, this will be 210 pieces. That's the smallest, the shortest one. But here it says that the greatest one, not the smallest one. So what is the greatest possible length of each of the smaller one? If I ask you what is the smallest possible length of each of the smaller piece of rope, the answer is 1. All the numbers are divisible by 1. But now we are looking for the greatest one. That means that we need to find the highest common factor of these numbers. To do this one, immediately we should write here 140, 168, 210. All numbers are divisible by 2 now. Are they divisible by 4? No. So let's start with 2. All are divisible by 2. Here we have 70. Here we have 84. Here we have 105. Now this number is not divisible by 2, right? What is the next prime number? It is 3. Are they divisible by 3? No, because 70 is not divisible by 3. Okay. Are they divisible by 5? Next prime number is 5. This one is not divisible by 5. All right. And next number is 7. Are they divisible by 7? Yes, right? So good. They are divisible by 7. If you divide this by 7, it is 10. 84 is divided by 7. What is it?
12.
12. And 105 is divided by 7?
14.
15.
Oh, 15. No.
Because that's the last digit is 5, right? So it should be either 5 or 15 or 25. 5 is too small, 25 is too big, so it is 15. Because the last digit is 5. And as I see here, 10, 12, 15, they do not have any common factor, right? So we can stop here. The highest common factor of 140 168, 210. That's equal to 2 times 7. That's equal to 14. So now if I divide these pieces, the first one is 140, second one is a bit longer, 168, third one is a bit longer, 210, this one is 140, and this one is 168, this one is 210, right? So actually I can just divide all of them into smaller pieces, right? Whose length is 14. That is the largest possible length of each piece of this one. At the time, this one, I can cut this into how many pieces? 10. That is 10 times 14. How about this one? If you divide by 14, that is 12. 12 times 14. And how about this one? If you divide this by 14, that is 15. Multiply by 14. That means that the first piece of rope, we have to cut this into 10 equal pieces. Each length is 14. The second one, we have to divide it into 12 equal pieces. The length of each piece is 14. And we have to divide the third piece by 15 equal pieces. Each length is 14, right? These are all equal length, right? Now using this one, Shaheen, actually in real life, sometimes you have 3 different pieces of rope, for example, or it can be anything. So how can I actually divide them into smaller pieces? Actually, the length must be the greatest possible length so that we have equal length of smaller pieces. So as you see here, if I add this 10 plus 12 plus 15, how many? It is 37 pieces here now we have. All pieces have equal length. That is 14 centimeters, right?
Oh.
Okay. How about question B? Can you read question B?
How many of the smaller pieces of rope of equal length can he get all together?
How many? We have already answered here, right? It is 37.
Yeah.
Because from here, I can get 10 pieces. From here, we can get 12 pieces. From here, we can get 15 pieces. So altogether, we can get 37 pieces of rope of equal length he can get altogether. Okay. Is it clear, Shahina?
Yeah.
Okay.
Oh, I've seen this question before.
Okay.
Two lighthouse flashed their light even
All right. Question 4, Shahina. Read question 4.
Two lighthouses flash their light every 20 seconds and 30 seconds respectively. Given that they flash together at 8 p.m., when will they flash next together?
Shahina, this question is for you. I will give you 3 minutes to solve this question. Okay, you solve this on a piece of paper. You tell me the answer. If it is right, fine. If it is wrong, then we will discuss together.
Okay.
Ready?
Yeah.
Okay, start. 3 minutes. Allah. Aslına girmez mi? Başka göç yaşasın bir şey göstermeye etkileyebilir yanında var olsun. Dimetörde muhasır edilir. Muhasır değil, muhasır değil, dimetörde muhasır edilir. Mol da mol, nasıl muhasır edilir? Mol. Yazıyorum. Actually, let's see. We have all to get the sample, or that's what you're doing. It doesn't. Oh, a very easy question. Finished?
8.
Eight?
I forgot the method.
So it says the two lighthouses flash their lights every 20 seconds and 30 seconds respectively. Given that they flash together 8 p.m., right? When will they flash next together? So that means that it's 2030, right? So actually this first one is every 20, 20, 20, 20, continuous. This one is 30, every 30 seconds and 30, 30, right? So that means that certain intervals, right, they flash together simultaneously. So that means that we need to find least common multiple of 20 and 30. Shahina, just mentally tell me, what is the least common multiple of 20 and 30? What is the smallest number that is divisible by 20 and 30?
10.
No, there's a smallest number that is divisible by 20 and 30. Least common multiple. It is 60, right?
Oh, you meant that. Okay, I get it.
Because here 20, 30, divided by 10, it is 2, 3, divided by 2, 1, divided by 3, 1. So if you multiply this, that is 60.
Oh, yeah.
So now it just flashes on, off. After 20 seconds, on, off. After 20 seconds, on, off, right? And this one is also every 30 seconds, on, off, on, off, on, off. But now we know that at 8 p.m., right? It says that they flash together at 8 p.m., right? And then when will they flash next together? So the lighthouse, right? They need to flash at the same time. Actually, it's a lighthouse, something like this. So that means that after 60 seconds, right? So actually during the 60 seconds, this one flashes 3 times. This one flashes 2 times, right? But after 60 seconds, they flash together at the same time. So what is the answer here then? At 8:01 p.m. Because 60 seconds equals 1 minute.